So, hi. Now we are going to start with the fact that how, when we see a chemistry question paper, how we should be responding towards it. So, since you know that the boards is about to start and we have our first paper, we have our chemistry boards in a month. So, there has to be certain techniques that we need to be following to make sure that our paper works the best, like we work the best technically, right? Now, there are certain things which are new in general, not in terms of the pattern for this year, but in general, that the way we are used to seeing boards versus the boards which we are going to see this year. Okay. For example, if I talk about our board paper, now it is composed of total 5 sections A, B, C, D, E. All 5 sections are having different marks. They have different choices internally, but all in all, there is no choice in any paper. All questions are compulsory, but internally they can be a choice. Okay. Now, whenever we see any question paper, whenever, so this is the major tip of the day, and that is that we need to understand one thing, that what is the mark for each section. For example, if I talk about section A, the marks are 80, which are devoted to it. For the second section, it has 14 marks. For the third section, it is 15 marks. Next section is 8. And the next section is again 50. Now, again a pro tip. Normally what happens, that the moment we start with the paper, we are more relaxed because it's early in the morning, we are more relaxed and handwriting is good. Yeah. So my personal suggestion would be that whenever we are starting with the paper, start with the theoretical part first. Always. Start with the theoretical part. And when I say theoretical, start with that portion of the theoretical part where you need to write more. Come on. Right? Wherever we have to write more. So instead of recommending you to start with section A, my recommendation would be to start with section E to maintain a pattern. Okay. Technically, it is section C and E, which requires more of your effort since they require more writing. Okay, initially your writing is good. Normally, what I have seen students is that initially you, for MCQ question, expectation is that if the first answer is C, you'll just mark it as C, right? And go over. But we don't do that. What do? We write C, then we try to explain it. But then in this 1 mark question, no one asks us to do that. We just ask to write the options. But because we are in that fresh mood, we do that. So wherever you need to, like if you have that much energy, it's best that you channelize it in the best possible space. So that is why section E, it just has 3 questions, but since they're long, they require your proper writing, explanations. So use it and grab 15 marks. Sida. Because towards the end, when the time is less and when you are trying to go for any one of the question of section E, see, it's a long question. If you're going to lose any question, that one question will be of 5 marks, right? Whereas towards the end, if you are even going to do 18 MCQ questions, most of these MCQ questions will be theoretical, mostly. Okay, there will be a few which require solving, but then mostly they will be theoretical. So it would be quick, isn't it? It will be a little quick activity. And you'll be able to give the answer better, right? So start with E. Though section D also, when it is a case-based study questions, so they can be based on MCQ type, because it's like 4 marks, right? So it can be an MCQ type, it can be an assertion reason type, the options which are there, or the sub questions which are there, and they can be very short answer types. Okay. So this part you can do, and then you can go to C, then do B, because B also contains very short answers. Another pro tip would be that if you talk about the marks for each case, normally the answer range, so that is all a myth, that the more you write in the examination, the better. Okay, that's not true. So what is the scenario? When you have to write the answers, you need a particular range. For example, the number of lines that you can write is irrespective of the size of the handwriting, right? Should be like if it is a one marker question, so the number of lines that you can use is 1 to 2. That's it. Either it should be over in one line or maximum 2 lines. If it's a 2 marker question, the line should be 2 to 4, not more than that. So technically the marks which each question carries, those many lines or maximum double of it. Okay. It should be enough to make sure that your entire paper gets easily covered in the answer sheet which is so provided to you. Okay. So it will be easily covered, plus it will be looking clean and accurate, right? So this was a few tips now. Now, in today's discussion, I am going to talk about how to deal with Section A particularly. Now, Section A is an MCQ-based question. Some of us just thrive and we do not understand how to give the right answer to an MCQ question. Now, if it is a solving-based question, okay, and we know the formula, or still it is easier for us, isn't it? Because we know the formula, we can solve for that formula, we can get an answer, and the answer would be one of the 4 options. I can easily tick it. But the problem happens when it is a numerical type of question, because there we have to apply some logic, some concept, and then come to it. And we do not even have to describe the concept, which or the logic that I have implied. Okay, so sometimes Section A, particularly assertion reasons, becomes a hard job for us. So how to simplify it? So let me start with the very first question. Again. Now, all 18 questions are mandatory, and normally in all our sample papers, we have seen like it's 1 to 14 to 15 questions which are MCQ, and then there are 3 assertion reasons, 3 or more. Now, first question. We saw that which one of the following will produce maximum depression or freezing point? This is the question which is given to me. Now, looking at that question, the question is from solutions chapter, right? It has been always told that in solutions, colligative properties are very important. Okay, there are high chances from solutions chapter from a question to be framed from Raoult's law, ideal and non-ideal solutions, and colligative properties. These are the 3 major things which you need to work in the self-assessment. Now, when I say depression of freezing point, so you know that delta TF is equals to I into KF into M. KF is the freezing point constant, M is the molality, and I is the want of factor. Now, why do I know that I have to use want of factor? Because if I'll see option number 1 and option number 2, they are electrolytes, whereas C and D are non-electrolytes. Okay. Now, for non-electrolytes, the I value is 1. Whereas for electrolytes, the I value may differ depending on the number of ions produced. Now, can I say that more the value of the depression in freezing point? So delta TF means the depression, the difference in the freezing, right? So this value is directly proportional to I. Now, the question asked is who will produce maximum depression or maximum differences observed in which case, right? So that means I have to look for the highest value of I. Now, in K2SO4, when it will break to give 2K positive ion and 1 sulfate ions. So the total number of ions generated are 3, 2 potassium, 1 sulfate. I value will be 3. In NaCl, it will break as Na plus and Cl negative. So the I value will be 2. As we discussed, higher the value of I, more is the depression and freezing point. Hence, my answer will be K2SO. Right? Now, the very same way, let's move to our next question. Okay. Normally, you do not have to solve this much. You just have to look for the I values. Because I'm expressing you how to work on this, that is why I'm showing you. You would be very quick. You see K2SO4, I is 3, NaCl I is 2, urea I is 1, glucose I is 1. You know A is the option. Same way, when I move to question number 2, fused NaCl on electrolysis gives dash on cathode. Right? All right. Now, no, without. Here, what is the scenario? The scenario is that, first of all, because they have asked electrolysis, it's a question of electrochemistry. Now, in electrochemistry, Nernst equation, the cells, okay, both electrolytic and electrochemical, they are very important. This salt bridge, what is salt bridge, what are the properties of it, that thing is very important. Products of electrolysis are very important, and Faraday's laws. Okay. Now, this is a question which is based on the products of electrolysis. Now, they are saying fused NaCl, right? Fused means molten. So there is a difference with molten NaCl versus aqueous NaCl. Right? Now, molten NaCl will have only 2 ions. Right? Molten NaCl has Na plus and Cl negative as ions. Now I know that cations moves towards cathode. Right? And anions moves towards anode. Right? So at anode, oxidation occurs, at cathode, production happens. So since they have asked me what will be the product formed at cathode, so at cathode, which ion will be moving? The cation, which is what? Sodium. So since Na plus is moving, this is going to produce sodium. If I talk about aqueous, there is H plus, Cl negative, Na plus, and OH negative. In this case, we have a competition between the cations as well as the anions. So had the question been, in the case of aqueous NaCl, what is produced at cathode? Then the answer would have been hydrogen gas. Because H plus would be specifically moving towards the cathode due to preferential discharge theory. So here the answer would be B. Correct? Does it make sense? Now, let's go to the third question. Again, the moment I move to a third question, it is a kinetics question. Now in chemical kinetics, order versus molecularity, zero order, first order, and the collision theories, they are important for this chapter. All right. Now, But then expression of rate equation is like the basic thing of it. So here they have used that information. And what did they ask us? They asked us that the rate of the reaction can be written in three ways. So this is the reaction which they have given. And they have said that the rate of reaction can be written in this way or this way. That is with respect to the reactant. And I know the reactant's amount is decreasing with time. The amount of product is increasing with time. Right? Now, they want us to know what will be the relationship of K and K dash, and what is the relationship of K and K double dash. Right? So how will I work on this? I know the fact that this is dependent on what? I know that this part, because we talk about the molar equations. So this part is equal to 1 by 4 d over NO2 by dt. This is also equal to dO2 by dt. Right? So if I'm writing in terms of this, it would be what? 4 by 2. So dNO2 by dt will be equal to 4 by 2 times this part, right? And this part can be written as this minus and this included. So we can rewrite it as 2K into 5. Right? Can I rewrite it this way? Now, so from here, when I talk about this part, so this information is written as K dash into N2O5. So on comparison, can I say that K dash is equals to 2K? Right? This is one thing that I can say. Another thing, if I want to know this relation with this relation. So again, I know that half minus d into O5 by dt is equals to dO2 by dt. So this part can be written as K into N2O5 because this is the part of this information. Iski value itni given hai, right? Now this part is given as dO2 by dt can also be written as K double dash N2O5. So from here on comparison, I'll get that K double dash is K by 2. I have got two relations and I think B will be the answer. Right? Does it make sense? If yes, then let's see with another question that how. So this is an important practice session where we are getting to know our questions. We can try solving each of them one by one with us. Okay, and let's see who gets faster because technically you should be getting it faster. Since I have to explain a lot, you can quickly do it. So which one of the following is a diamagnetic ion? Okay, so I know the meaning of diamagnetic, which means there shouldn't be any unpaired electron. All the electrons must be paired if you want any ion to be diamagnetic. Okay, so cobalt is 27. So 27 technically means argon 4s2 3d7. So the best way to know it is look at the first number. This number will go to 4s. Second number will go to 3d. Right? So the configuration becomes 4s2 3d7. But since it has to lose 2 electrons, the 2 electrons will be lost from 4s. So the configuration is 3d7. Now, d7, odd number of electrons, has to be a possibility that one of the electron must be unpaired, isn't it? Because there are total 7 electrons. It is odd number. So all the electrons cannot be paired up. Okay, so this cannot be done. Ni2 plus 28, electronic configuration 3d8. Though it is even, it is not mandatory that all the electrons must be paired. So in this case, at least we'll do an effort. For previous case, we did not even do the effort. So I have 5 orbitals. I'll first fill the electrons singly, then only the pairing will start. So there are still 2 electrons which are unpaired. Okay. Cu2 plus is having 3d9 configuration. Now, since it is not having 9 electrons, odd electrons, we do not even do it because for sure there will be an unpaired electron. But the moment I go to zinc 2 plus, it is having 3d10 fully filled. Total 10 electrons is maximum. You are already having 10. Iska matlab, each of the electron is paired up. So that is my answer. Plus, I already know that A, C, B cannot be the answer. So D has to be the answer. Right? All paired electrons. Yeah. Now, this is not exactly a particular chapter's question, but this is an in general question. Though I can consider it as a coordination chemistry question or a D and F question. Okay. Basically, any inorganic. Now I look at 5th question. Now in the 5th question, it is a question of coordination chemistry. For sure. It's a nickel carbonyl compound. Now in this tetracarbonyl nickel is the compound. Now I know that carbonyl is neutral molecule. Therefore, nickel will have, so if I consider this as X, this is 0 because it's a neutral molecule. And the overall charge is equal to 0. So the charge on nickel will be 0. Though, I guess you are aware of the fact that all carbonyl compounds, right, have the central metal in their 0 oxidation state. Be it FeCO5, CO2, CO8. Whenever it's a carbonyl, just carbonyl, okay? So if there is any other ligand involved, then the answer may vary. But if it's just a carbonyl compound, NiCO4, FeCO5, cobalt carbonyl compound, Mn2CO10, all carbonyl compounds will have the central metal in their 0 oxidation state. Right? Then, let's see the 6th question. What are the products formed by the chlorination of methane in diffused sunlight? So we know the fact that if there's sunlight, right, Ayush? So if there's sunlight and we are doing the chlorination of methane, which is a free radical substitution reaction. Okay, the good part is it is a chain reaction. So this will keep on happening, right, Ava? So it will keep on happening till the time all the hydrogens are replaced with chlorine. So one case could be this. Another case will be 2 hydrogens are replaced. Another case will be 3 hydrogens are replaced. Another case would be all 4 hydrogens are replaced. So technically, all 4 products can be found. Okay. And I think already they have given you 3 of these. So the answer is all of these. Right. Now, in the next question, they are asking you about the formula of copper pyrite. Now, what is copper pyrite? What is copper pyrite? It is an ore of copper, right? It is an ore of copper. Right. Now, yes, Abha and Ayush, the answer would be C. And technically, though you do not have metallurgy chapter, but we do have D and F, and that information is provided there. Okay. So this is the part, like whenever we talk about S block, P block, D and F, right? So any blocks whenever we study, so there is an information which is given in the very beginning related to the occurrence, okay, of a group, the particles of that group, the elements of that group. So in that occurrence, they have given certain names of the ores. And yes, the things are coming from there. Another question is the carbon atom in the carbonyl is. So carbonyl group is C double bond O. So if I talk about the carbon atom, right, Ayush Abha? So since there is 1 pi 3 sigma bonds, right? 3 sigma and 1 pi. The hybridization is sp2. So you're aware, on all 4 sigma bonds, sp3. If carbon is having all 4 sigma bonds, sp3, 3 sigma 1 pi, sp2, 2 sigma 2 pi, sp. Right? Then we have a compound in hydrolysis gives primary amine. Compound on hydrolysis gives primary amine. Then the compound is, right. Okay. So what can be your guess? Now, what is analyte? What is an analyte group? If I ask, like, so you need to understand a few things that, okay, if you talk about any of the part, like acid analyte or analyte group, amide group, so what do they mean? What do they mean? Now, if I talk about analyte group, right? So analytes are basically the so for example, if I talk about this is aniline, right? Now in this aniline, if I'll replace one of the hydrogen and connect it with this part, So this is an analyte. Whereas what is amide? The difference between these two is that in amide, our C double bond O N is in the form of NH2. Whereas in analyte, the nitrogen is also substituted with something, right? So it is like an amide, but where the nitrogen is substituted. So the nitrogen can be substituted with an R group, okay, or an aniline group. So when it is substituted with an aniline group, we call it as analyte. Okay. We also call them as the phenylamides, N-phenylamides. That means the nitrogen is substituted with the phenyl group. Now, there is cyanide. Now, if I talk about RCN and I'm doing hydrolysis, like acidic hydrolysis, so I'll get RCOH group. Because we know that this is the part which breaks, since this is the derivative of an acid. And we get ammonia. Here, when it breaks, so again, because it's a derivative of an acid, so CONH bond, with a CN bond will break. So again, this will also give you RCOH and ammonia. If I talk about A option, as I said, this bond is breaking. When this bond is breaking, I'll again get RCOH, but this time I'm going to get an aniline. Now, aniline is what? Can I say it's a primary amine? It's a primary aromatic amine, but it is primary in nature. So the answer will be A. Because I want that compound, which on hydrolysis should give me a primary amine. Right? Then we have 10th question, what is an enzyme? So I think this is the first or the second line of your biomolecules chapter, that all enzymes are proteinous in nature. They're made up of amino acids, right? Ayush, Abba. Yeah. Then, if I talk about 11th question, which of the following aqueous solutions should have the highest boiling point this time? So I know, and this time it is not the elevation of boiling point. This is the boiling point value. So I know that delta TB is again equal to I into KB into M, which suggests that more the concentration and more the value of I, more is the boiling point difference, right? And higher the boiling point difference, higher is the point, because the boiling point has to increase. So more difference means it will increase to a higher value with respect to 100, right? Now, I just looked for the want of factor, and we have just said that I is the number of ions to which it is dissociated. For example, if I talk about NaOH, NaOH dissociates into Na plus and OH negative ion. So it will produce 2 ions. In the second case, which we just discussed, 2 Na plus and 1 sulfate, total number of ions are 3. In C option, 1 is ammonium ion, 1 is nitrate. Again, total number of ions are 2. In KNO3, K plus, NO3 negative, total number of ions are 2. So more the number of ions, more is the boiling point difference, and higher will be the boiling point. So the answer would be B. Right?
Yes, ma'am.
Yeah, right. Then we'll move to the 12th question. Which of the following statement for order of the reaction is not correct? Okay. Now this is one of those questions which are theoretical. And they want to know which is not correct. So these words are very important because we generally miss out this. Order can be determined experimentally. This is the correct value. Order of reaction is equal to the sum of the parts of concentration terms in the differential rate equation. This is also true. It is the sum of parts, which we write it as alpha and beta. It is not affected with the stoichiometric coefficient of the reactants, true, though it is an incomplete line technically, because it is not affected with the stoichiometric coefficients only in case of complex reactions or those reactions which occur in more than one step. Whereas if it is an elementary reaction, then order is equal to molecularity, and molecularity is dependent on the number of stoichiometric coefficients. Okay. And D option says order cannot be fractional, which is wrong. Order can be fractional, isn't it? It can be half, it can be 1/4, it can be -1/2. So order can be fractional. We know that it can be 0, fraction value, positive, negative, anything. So the answer would be D. The answer is D, though C option is not a very good option which has been framed, since it can give you different meanings. Right? Then, again, in the 13th question, the transition elements have a general electronic configuration. Okay. Now, B doesn't make sense because what is this? And but then what? S, P, D, F, they have not informed. Right. Then before D, you do not fill P, because you know that first S is there in the periodic table. Then there lies D block. Okay, there's F, which was lying just in between the D. And then comes the P block, which is towards the end. So you cannot fill the P electrons before D. A is also wrong. NS having a value of -2, that doesn't make sense. Right? Because it's just 2 electrons. So it is 1, 2. It's a positive number. How can it be a negative value? So the answer is C. Right?
Excuse me, ma'am.
Yes.
Ma'am, I had a doubt. Like, I have seen some books in which they rearrange the position of the orbitals. Like, for not for d orbital, but in case of lanthanoids and actinoids, they just give us the way of writing. Like, is it? Can we do that while doing the electronic configuration?
Like in terms of like first you're writing NS and then you're writing N-1D?
Yeah, like I've seen some books that do that.
Yeah, technically that is wrong as per Aufbau's principle. But yeah, this way can be done only if the arrangement is in the line of N plus L.
Yes.
If it is in sync with Aufbau's principle, then yes, you can do it.
Okay,
right? Yeah. Then 14th question is mercury chloride reacts with ammonia gas and forms white precipitate. Okay. The molecular formula of that white precipitate will be Hg. So when we see a question like this, that there is mercury chloride, which is reacting with ammonia gas, can you see, like, have you seen anything of such sort? Mercury chloride reacting with ammonia. Any such way? Or was it in any sort of cell which we have? Did you have any sort of cell where this sort of thing can be used? Yeah, so there was a mercury cell which is used in the electrochemistry. Now they have retrieved the information from there. They have retrieved the information from there, like they have asked the question, they have framed the question from that very values. Okay, now how does that happen? So if you talk about this reaction, the bright precipitate so formed is because of this. And apart from that, you also get mercury plus ammonium chloride in this reaction. You also get this part. So the white precipitate is due to this formation, right? And it is given in your books. Clear? And then let's move to the next thing, and that is your assertion reasons, which are real trouble for us. So, 15th question, if I'll see, 4-nitrochlorobenzene undergoes nucleophilic substitution reaction more readily than chlorobenzene. So this is chlorobenzene, and this is 4-nitrochlorobenzene. Now in this, there is NO2 group, which is electron withdrawing group. So electron withdrawing group will increase the nucleophilic substitution reactions, the rate of nucleophilic substitution reactions, though it is not a characteristic reaction of benzene. But because of the presence of NO2, since it is withdrawing the group, it is withdrawing in nature, it increases the nucleophilic substitution. Okay. This is the assertion. Now, when it comes to reason, now we can have the chlorobenzene undergoes nucleophilic substitution reaction by elimination addition mechanism, while 4-nitro undergoes it by addition elimination mechanism. Does this reason make sense to you? Does this make sense to you? Yeah. Because they both have the way that they react. Okay. Now, in this first case, we have something called the benzyne mechanism. Okay. So there is a benzyne mechanism which is observed. Now, the moment you talk about this, it is easier. The reason is because of the electron withdrawing nature of nitro group, which decreases the electron density on the benzene ring. Because of that, the nucleophile is capable of attacking the benzene ring more easily. Okay. So that is the scenario. So here I can say that assertion is true, right? But the reason is incorrect. Yes, in both the cases, the mechanism is same.
Ma'am?
Yes?
Ma'am, can you give an example of addition elimination mechanism?
The addition and elimination mechanism. So first, yes. See, this example would be when you have, suppose you have carbonyl, right? And there is this ammonia that is treated with it. Okay. So what happens in this case? You know that there is formation of this OH and NH2, right? So this is addition, correct? First has been added. Then what happens? We say that OH and NH2 on the same carbon are not stable. So they will remove as water. Okay. So then what do you get? This part. So this is what? Elimination step. So first something is being added and then there is some particle which is eliminated out, removed out. So this we call it as addition elimination process.
Okay, ma'am. Understood.
Welcome. Then we come to 16th question. It says hydrolysis of sucrose is known as inversion of cane sugar. This is something we've done in the fact that whenever sucrose is hydrolyzed, you know, it gives you glucose plus fructose, right? And the entire optical activity changes. Okay, so sucrose is dextrorotatory, whereas this mixture which you get, this glucose and fructose mixture, is levorotatory in nature. So in terms of optical activity, there is an inversion which I'm observing. Okay, so this is a true statement. Then they are saying sucrose is a disaccharide. This is also a true statement. But this is not the reason for the fact now that sucrose hydrolysis undergoes inversion. Like, why is it known as inversion of cane sugar? It is known as inversion of cane sugar because sugar is having a change or inversion in the optical activity from dextrorotatory nature to levorotatory nature. That should have been the reason. So here, both assertion and reason is true, but reason is not the explanation. Right? Then we have another question. According to the transition state theory for the formation of an activated complex, one of the vibrational degrees of freedom. Okay, I think this question is incomplete. Okay. According to this transition state theory for the formation of an activated complex, one of the vibrational degree of freedom. And यहाँ पे एक full stop आया हुआ है, तो I think कुछ तो है जो यहाँ पर missing है. तो ऐसे question normally अगर आपके boards में भी आते हैं, so you can raise up and eventually they will give you grace marking, like if it is an incomplete question. Okay, because boards में unlike schools corrections बहुत कम होती है. ऐसे नहीं है कि कोई आएगा और बोलेगा कि ये correction आई है boards की तरफ से. ऐसे नहीं होगा. Okay. Then we'll move to 18th question. Glycosides are hydrolyzed in acidic conditions. And glycosides are acetals. Okay. So glycosides are the ones which are present in case of your lipids. Okay. They can be easily hydrolyzed in acidic conditions. Right. A glycoside is you have also your glycosidic bond, which is present in your, like basically in lipids, we have ester phosphate bonds. Majorly these glycosides are present in carbohydrates, sorry. Okay. Glycosides are present in carbohydrates. So when you talk about the carbohydrate bond, so what is the scenario here? When we talk about the glycosidic linkage, it is like an ether bond, right? The two carbons are connected by an oxygen. So it's like an ether bond. Okay. So there are hydrolyzed in acidic conditions. So when you provide an acidic condition, what will happen? This bond will break. This bond will break. So yes, it can be hydrolyzed. And they are saying the reason being that the glycosides are acetals. Now, if we talk about the glycosidic linkage, okay, so the glycosidic linkage cannot be called as an acetal, because acetal means when the same carbon is having this is an acetal. On one side there is hydrogen, on one side there is some R group, one side and the other two sides. So there are two OHs. Oh, sorry, not two OHs, two ethers which are present. Right. Two ethers, when they are connected to the same carbon, then we call it as acetal. So, but the mandatory condition is they should be present on the same carbon, two ethers. But that is not the scenario in glycosides. Right? We are not going to have two OR groups present on the same carbon. They can be hemiacetals or hemiketals, but they are not acetals. So reason is incorrect, but assertion is true. Assertion is correct, reason is incorrect. So that will be my answer. Right. So that was the part for this discussion of section A. Now in our next session, we will be continuing on how to attempt section B and section C part. All right, so stay tuned and we'll be going forward in the same case. So I have the same paper, we will be working in the same progress. All right, so that's all for today. Take care. Bye.
Thank you.
Welcome.